All right, how's everybody doing? Welcome back to another day, another week of the DSKUS program. Hope everybody's having a nice week. Hope everybody is, I think you guys are working on your annotated bibliographies right now, something like that. I think that's what you guys are probably working on. And of course, we'll have an all-class meeting as well. Probably by the time you watch this, that'll all be done. So maybe a relevant for you guys in this particular week. But hold on just a second. This week we're going to talk. I just noticed a small mistake in my slide. Let me fix this. I'm annoyed now. There you go, April 7th. So we are this week we're going to be talking about something called computational thinking. This is going to be part of our brainstorming process is what we're going to talk about. This month is all focused on brainstorming, and we're going to have you guys go through a series of processes to kind of come up with a good idea that you can then try to execute on by doing some analysis. But computational thinking, I'll try to keep this short this week, but computational thinking lies at the heart of data science and computer science as well. It's a critical thing to be able to take a big problem and break it down into sub-problems so that you can try to solve it. I mean, that's what modern computing is all about. And to be honest with you, that's what modern data science is about. Computational thinking is core to a lot of what we do. A lot of times if you try to solve the whole problem, it just, it never works, right? It's like trying to stare at a Sudoku puzzle and just hoping that magically you'll figure it out. It's probably not going to happen. Much better to kind of focus on individual parts of the problem, come up with solutions for those, and then put it back together. And then you can solve the whole big problem, right? I mean, that's a common strategy that humans use to solve lots of problems. A core part of solving these kinds of or a core part of computational thinking is the creation of algorithms, right? This is what made Alan Turing really famous because he defined a lot of this stuff, right? So one thing that we should probably talk about is what is an algorithm. Now, if you've taken my classes, I talk about this a lot, so you probably already know, but if you haven't taken my classes, you may not know exactly what this is. I mean, you've probably heard the term algorithm, but you don't necessarily know exactly what we mean by it. But it's fundamental to data science and computer science. I mean, machine learning is essentially the creation of algorithms. That's what it is, honestly, to solve different types of problems in different ways. So what is an algorithm, right? Well, the best way that I can think of to define an algorithm is it's just like making a pie, right? An algorithm is anything where we have some input, some processing steps, and then some output. So if we're making a pie, our input is like the ingredients that go in the pie, right? Like some eggs, maybe some milk and some butter and some sugar. And I don't really cook. So I use this example all the time for this, but I don't really cook, so I don't really know. But there are ingredients, right? And then you take the ingredients and then there's some steps. Maybe we mix the eggs and the milk in a bowl, and we whisk it around, and then maybe we set that aside, and then in a different bowl, we put some sugar and some breadcrumbs or whatever, and then we make the crust, and then we put the filling inside the crust, and then we maybe bake it, and then maybe we let it rest, and all these steps, right? And then at the end, there's this output, hopefully a delicious pie, right? Hopefully you end up with a delicious pie. Probably not if I made it, but if my grandma made it, you'd end up with a delicious pie, right? So input, processing steps, output, right? So anytime you follow a recipe, like a pie recipe, you're making an algorithm, right? But algorithms kind of go beyond this. Anything that has these three components, this input, processing steps, output, is an algorithm, right? Anything, right? And we use this all the time in data science when we're trying to do things. Maybe our input is some data and our processing steps are some sort of analysis, and then our output is some sort of solution, right? That's an algorithm. Algorithms come in all forms. We use them in robotics, we use them in AI, they're all over the place, right? They're ubiquitous, right? in terms of this particular class, really what we're focusing on here is data-driven policy design. So what we want to think about for this class, because we want to impress the US government and the Korean government, is we want to come up with algorithms that are a set of steps to complete a task, which is common through data science, machine learning, all that kind of stuff. But hopefully the output of our actual, hopefully the output is going to be some sort of policy that can be implemented, right? And so we need to think about the input in terms of the actors, the policy actors involved, the resources, the labor, the human capital, the money maybe that's necessary, whatever inputs are needed. We need to think about the processing steps, which, they're going to be things that need to happen. Like we're going to have some human capital and we're going to have some resources, or we're going to have some money. And then we need to do things with that to, achieve some goals. And then the output, like I mentioned, should be some deployable policy. And that policy should be, constructed in a way to achieve our policy goals. And the policy goals are going to be defined by the question that you were given at the beginning of the project. If we don't achieve those goals related to the policy, sort of the initial policy project topic, then we've kind of failed, right? So part of what we need to do in this class is think about this stuff very carefully, and how can we actually break the problem down into sub-problems and create these algorithms that kind of lead to a policy or a set of policies that actually accomplish some policy goal. And this is going to be very, very important, and it's going to be hard. I mean, just to be blunt, when I teach these classes, for data science, not just policy related data science, but just data science in general, the brainstorming part is always the hardest part. Most people are comfortable reading some papers, maybe finding some data, maybe running some machine learning models, whatever. But actually brainstorming, it's a difficult process because it requires just a lot of creative thinking, and nobody really knows what the answer is. And so it's not clear exactly what you should be doing. And it just is what it is, right? But if in order to be successful in data science, this is a necessary part of the process. And so we're going to do it. So we're going to do it in this class. So one of the things we want you to do in the coming weeks is actually work on something called design sketches. You can Google this, design sketches. You can also Google something called algorithmic workflow or algorithm workflow. And you can look on Google image search and you'll find all sorts of examples of these. I will show you a few today, but you can also Google this stuff and find lots of stuff. So one thing you can look for are like Google design sketch or system design sketch, right? So if I go from here and I go to here, and I'm editing paper, so that's off topic. If you just go to Google and you type design sketch, and you go like an image search, you're going to find a lot of, well, people use design sketches for lots of stuff. But if you actually add the word system design sketch, you're going to find a lot of stuff like I just showed you. You're going to find stuff like this. You're going to find people designing engines and machinery and other things, but you're also going to find design sketches like I just showed you, right? Like this. You can also look for what's the other one, process design sketch, right? And you'll find lots of examples of people mapping stuff out. Another one you can search for, another one might be good. Let me put quotes around it. This will change the answer. I think we get similar things. But another thing to search for is something called algorithm design or algorithm workflow. I usually like this, algorithm workflow, these kinds of things. So these are similar to what you just saw me. And you'll find these for all kinds of topics. I mean, you can find this stuff if you look like if you look for like a hospital. That's a high school hospital. But you can find all kinds of stuff here where they're like doing stuff like this is an admission to fill beds in a hospital, right? So if you Google these algorithm workflows, system design sketches, algorithm design sketch, I'm just mixing these words together in different ways, and we come up with all these examples. I don't know what some of this stuff is. But you can come up with all these kinds of different examples of what these design sketches look like, right? A process workflow, it's another one people like to use. Process workflow sketch, all this stuff. So all these terms, process, design sketch, algorithm workflow, apparently I can't spell. You're going to find all these examples of people mapping these out, right? Here's an example of how we onboard new employees if we're running a company, right? And we can use these too. I haven't actually tried this, but I'm going to try it right here. I'm sitting in here. Policy design sketch. I don't know if this will even work. I've never tried it, but yeah, we'll come up with a few things. Maybe policy design workflow. There you go. This is the kind of stuff we're looking for. You know, here, you know, I don't know how helpful that is, but this is the kind of stuff we're looking for in terms of these flow charts, these graphs, these sketches of here's our input, these steps happen, maybe the input comes at different times, and then there's some sort of output, which is hopefully a successful policy, right? Hopefully you guys design something that is actually a successful policy that that the governments can implement to solve the problem, right? I mean, that's the whole point of all this. So there are these system design sketches. You can find lots of them by Googling system design sketch. Wait, I have another question. Let's see if this works. Live coding is always a bad idea, but curious if this, I'm curious. I don't think I searched this. What happens if I put all of these on here? Oh yeah, that did come up with a lot of things. Actually, if you just search system design sketch all together, a bunch of interesting stuff. Anyway, that's off topic. So anyway, in the interest of time here, so like I say, you can find lots of this stuff by Google searching for images, get some ideas for all kinds of different problems. Here's an algorithm design workflow. And this is what we want you guys to do, to start to kind of map out, like, okay, here we're going to have these inputs, we're going to have this, and then they're going to flow in, and then these steps are going to happen, and then there's going to be some output, or maybe several different outputs, or maybe there may be actually different branches occurring, right, in your kind of workflow. So these design sketches are you just kind of mapping out, okay, if we were going to solve this problem, what would we do? What would we start with as our input? What would be the steps that would occur using that input? And then how would that result in some output that actually achieves our policy goal, right? How do we create this output? Now, thinking algorithmically, thinking computationally. It's also possible to create some pseudocode. So sometimes we do this. This is an example of some pseudocode to control a robot in a museum. Probably not all that useful for what you guys are working on, but you can see we have a series of steps, and there's some variables, some parameters that we control. So sometimes people create pseudocode along with the design sketch to describe how the process works and what the steps are. So that's something to think about. You also may want to think about the actual infrastructure components. So it may be that the data doesn't exist. And so we're going to have to, you may have to propose ways to actually collect the data in an ongoing fashion. If there's no source for some data that you may actually need to devise a policy, you know, maybe you have a data set, but it was collected in a one-off manner. But in order to make your solution work, we're going to have to be collecting data in an ongoing fashion. Then you're going to need to think about, okay, what kinds of sensors, what kinds of databases, what kinds of architecture are we actually going to need to put in place to actually be able to deploy the policy in a way that we can constantly monitor whether it's working, right? If we're going to do something with, you know, renewable energy, then we might want to be able to track, like, you know, the amount of energy that's being produced over time, right? Well, then we're going to need some infrastructure to collect that data. Maybe that infrastructure exists, maybe it doesn't, or maybe it exists, but we can't directly access it. So as a government, we're going to have to put things in place to allow direct access. And we also may need to then also deploy things that can, components that will allow people to access the results of our models, right? Say we have models that can predict when certain energy needs are going to spike. Well, we may need to be able to allow our system to provide that information to government officials, to private citizens, to managers at the electric power plants, right, or whatever, because otherwise they're not going to be able to use the information. So we need to think about how we're going to collect the information, but also how maybe we're going to deploy that information back out to end users. And then the end users may be a variety of different groups. So we'll need to think about that as well. One thing I'll stress here is when you're designing an algorithm, you should always start with the common sense approach first, right? Start with something simple and then add to it. Don't start with something overly complex. Start with something simple and then make it more complex. A lot of people fall into this trap of building a house that looks like this, and then you can never add to it. If something breaks, you can't figure out how to fix it. It's too complicated, right? If you do start brainstorming and you realize it's becoming complicated, another thing you can do is simplify parts of it by taking the complexity and figuring out, okay, how can we make this simpler? Because when you do that, when you simplify things, you basically are creating a new foundation that then allows you to create new complexity on top. And this is really, this is the core of modern science, is taking complicated ideas, making them simpler, and then adding to it, right? This is how we come up with better and better solutions to things, better and better ideas. Is we take complex ideas that we use to explain things, we simplify them, and then we make things more complex on top of them. So when you guys are working on this, I mean, I think that any proposed policy should adhere to the same principle. Keep it simple, stupid, KISS, right? Start with simple solutions and then slowly make them more complex. And if it gets really complex, look at ways to take parts of it and simplify them so you can add more features, add more complexity, right? But you guys are really gonna have to brainstorm and think about all the different stuff that you may want to put in your design sketches. You have to kind of think about what are all the possible inputs that we may need to consider. What are all the possible outputs? Who may need to see the information we're collecting? Who are the end users? Should we develop user interfaces? And do they need to be in real time? Should they be on smartphones? Should we put them on a website? Should we have sensors that we embed in the environment so we can collect data in real time? These are all things that you guys are going to need to consider if you're actually going to design a solution that can be deployed, right? All these things, the policy goals, the actors who are involved, the potential side effects, everything we do here, these are all things we need to consider, and we need to consider them in a data-driven way, right? You can kind of think of this as your first attempt to create a rough framework around what will hopefully become your eventual policy proposal. It's not finished. You will kind of continue to add to this, but this is your first attempt to kind of start to formulate something, a rough draft, if you will, right? More than likely, your initial design sketches are going to be wrong, and that's okay. That's okay. Your goal is not to come up with a perfect solution the first time. In fact, that's a stupid goal. Nobody comes up with the perfect thing the first time. Your goal is to come up with something that kind of makes sense, that we can look at, evaluate, critique, and then try to improve upon later, right? The point is to start giving substance to your problem, right? To take your problem and really start to think about it. And then you'll submit these, we'll look at them, we'll give you feedback, and then you can kind of start to improve them. And once we go through this brainstorming process over the next few weeks, then in May, we'll actually start trying to execute, right? We'll start doing the machine learning. We'll start trying to do some analysis to back up parts of our design and actually see if the data backs up what we're actually proposing. Because we're going to need to be able to convince the policymakers, the government officials, that what we're proposing is actually rooted in the data, that it has a solid foundation. It's not just some crazy idea based on somebody else's opinion, right? So it's okay for these not to be perfect. Don't try to make them perfect. Just try to brainstorm as much as possible, come up with as many ideas as possible. And that's really your goal right now, right? So So the best place to start here is with one idea or maybe two or three based on your EDA or your background research, right? So you've done the background research and you should be starting to work on your EDA now, hopefully. And the idea is to distill the idea into its simplest form, like create an algorithm or a set of algorithms, and then iterate on the idea. Add features, components. What are parts of the problem that we haven't addressed? Should we add things to address those parts of the problem? Or is there anything we forgot about? Anything we're missing? Did we overlook anything? Is there anything we didn't think about? Oh, what about, oh, we didn't think about what happens, what happens with this group of people or that group of people or in this place or that place, or what happens if this happens? What if this event occurs? Well, this will screw everything up. Well, we should probably have something for that, right? And then you just keep going in a loop, keep iterating, keep iterating, keep iterating and adding to it until you've thought of everything possible, until you just run out of ideas, scrape the barrel dry. And that's your goal. That's your goal for the next month, is to do this. So for next week, I believe in next week, you'll have the EDA, the exploratory data analysis, which will be due. We've talked about that in previous lectures. So if you do not remember, go back and look, but we're expecting you guys to do 5 or 10 analyses of your data set, of these sort of data visualizations, and then write about, these are the interesting things we're finding, and talk about the hypothesis you're coming up with. And then in a couple weeks, you're going to be expected to turn in your design sketches, which are similar to what I just showed you. And you can go on Google and search for these things and find other examples. So this is going to be probably one of the hardest parts of this process, but I think it's also going to be one of the probably one of the maybe most fulfilling parts, because it's really a chance for you guys to be creative before you start to do the analysis and really kind of interject a lot of your own ideas into things. And so hopefully it goes well. If you guys struggle with it or you're not really sure what to do, ask your mentors. Feel free to email me and be like, are we doing this the right way? And we'll try to help you guys. So if you kind of get lost a little bit, reach out and let us know, and we'll try to help you. This part of the process, I think, is hard, but it's also really important. So we need to make sure we do a good job. So I'm gonna let you guys go, get back to your week. But if you have any questions, please let me know, and I will talk to you guys soon. All right, thanks.